let's continue with lesson 2. We're going to continue working with the calculator and show you how this all works on a calculator as well. I do want to review a little bit. We want to kind of rewind here a little bit on multiplying positive and negative numbers. As you recall, when I have a -2 times -3 times -5, I can model this as the opposite of 2 times the opposite of 3 times the opposite of 5. So what I'm allowed to do is I'm allowed to pull the negatives out of the problem and just focus on the multiplication. We know 2 times 3 is 6, and 6 times 5 would be 30. And then I got to take the opposite of 30, which would be -30, take the opposite of -30, which would be positive 30, take the opposite of positive 30, and that would give me back to -30. Another way to pick up on it is just think like a light switch. Negative, positive, negative. So 1 negative is negative, 2 negatives is positive, and 3 negatives is negative. And that's easier to keep track of if you think of it like a light switch. So therefore that would be -30. We can also model this on a calculator. The calculator can use parentheses to represent multiplication. So on the calculator, we turn it on, and again, if you hold down the on button, hit the clear button, get that memory cleared if you need to. So again, I can do like open parenthesis, -2, close parenthesis, open parenthesis, -5, or -3. We'll hit a delete button up there next to the toggle directional pad button. There's a little delete button, and I can hit 3, close parenthesis, open parenthesis, -5, close parenthesis, and that looks correct. Hit enter, and that does give me a -30. So we can also just put it in the calculator and get that -30. Also want to look at a problem working with multiplying and dividing. So let's look at 12 divided by 6. Let's see. Let's go. "12 divided by 2 times 6. Let's look at that example there. In working with division multiplication, like I said, you can just fire that into the calculator. It understands the order of operations. Remember, you have to multiply and divide together from left to right. Something else to pick up on, though, is if you remember, division is actually the same as multiplying by the reciprocal of the divisor. So division, I'm allowed to change to a multiplication problem by using what we call the reciprocal. Now, the divisor is what you're dividing by, so 12 divided by 2, so 2 is actually our divisor. So what I'm allowed to do in math is I'm allowed to change this to 2 over 1. And what I can do is I can take the reciprocal of that. And the reciprocal basically means I can flip it, turn it upside down. So what I'm allowed to do in this problem is I'm allowed to go 12 times, I'm allowed to change division to multiplication. Let's just use a dot. So I can change this to 12 times, and I can flip the 2 over 1, and the reciprocal 2 over 1 would just be 1 over 2. So I can change it to a fraction, 1/2, and then multiply by 6. So I can have that problem. Something else we can pick up on is, that's kind of neat, is the multiplication symbol can be replaced by the word of. So I can kind of use some fraction talk here. So where we see this 1/2 times 6, I can actually look at that as 1/2 of 6. And 1/2 of 6 kind of means to divide 6 into 2 pieces and take one of them. So 1/2 of 6 would turn out to be 3. So in doing this math over here, again, multiplication order does not matter. I can actually go 1/2 of 6 and go then 12 times 3, which turns into 36 that way. So I can do that problem like that. A few other things to bring out besides division being changed to multiplication. Let's talk about an algebraic extension as well. Let's pick up on a little bit of vocabulary. So vocabulary we have is, I can write an expression for the product of 2 and 5. Again, product is a key word here. In math, the word product implies multiplication. So to write an expression for the product of 2 and 5, what that means is you have to multiply 2 and 5. And I can show that expression by using parentheses. I can go 2 in parentheses times 5 in parentheses, and that would be an expression that models the product of 2 and 5. It's just a multiplication problem. One other extension we want to look at is we want to write an expression for twice a number. And let n represent the number. So now we're throwing in the variable stuff. So write an expression for twice a number. Twice kind of means to double something. And double really just means to add it twice or multiply by 2. So what I can do then is to write an expression for twice a number and let n represent the number, I can go 2 times n, or a lot of times we'll just write that as 2n, where 2n represents 2 times n. Okay, a lot going on there, but hopefully you can find that information.